If you guys see over here, this is heavy duty vehicle multiplexing part 3. Okay? And it's basically a continuation of part 1 and 2. So what we're gonna do here is, don't worry about me over here. Now I did put a new, I went online, I did another, instead of Swede wanted AOL and all that stuff. There's a new one. I haven't really tried it out. I went on GoDaddy and I want to change a few things out, but you know, don't worry about the rest of it. Again, as I usually say, you know, it's not about me. It's, you know, hopefully I can give you guys something, you know. So what are we going to try to cover? We're going to have a continuation of the multiplex, like I said, part 1 and part 2. We're going to do some basic diagnostic strategies pertaining to CAN. We're going to utilize common tools, or have a few slides with, you know, what makes sense, what doesn't. Definitely going to look at some resources for information, and we'll do a few things with recommended wiring practices. Those wiring practices, I'll be very honest with you, wiring terminals and stuff can be a whole hour all by itself. And then I'm going to actually do a diagnostic, kind of a demo case, and I'm actually going to use a WAPCO system, because I found it very, because I do ABS2 and stability control and everything, actually in my brake classes, but I found that a easy path, an easy way to us working at it together and see what kind of trouble we can get into. So, you know, now we're going to start up with wake up first. Okay. Yeah, I'm trying to wake up too, guys. It's been a long week, and it's going to be a long week because we're going to try to catch up for the Thanksgiving coming up. By the way, in case I forget to, happy Thanksgiving coming up for all you and all your families. Now, wake up. Many controllers are programmed for a sleep mode. For sleep mode, excuse me, I told you I'm trying to wake up. I injured my shoulder. I'm still trying to get over it, so it's screwing me up a little bit. Okay? There's so many different strategies. Okay? Absolutely, we're not going to be able to describe every single one, but you know, there's some common strategies that you might encounter, so I bullet pointed them. You know, some modules might need a wake-up message from another module to wake up. Some networks might only require ignition power to wake up all the connected modules to it. And again, some networks might have an extra circuit applying voltage on a network to wake up. You know, you don't see that often, but again, you never know what you're going to run into. And in that particular case, the voltage would be a signal, not a power source for the modules. In some networks, a master module called power mode master. I mean, there's so many different words for these nodes. Wakes up, and boy, once it starts talking, kind of it's a wake up call. Actually, it'll initiate wake up for all the other modules. You know, but why would we care? Eh? Diagnostics. Just think about it. You know, I'm not knowing at what level everybody is at. Okay. But absolutely, it's a good thing to know if you're looking at trying to isolate modules for testing. Don't forget the parasitic draw. How can you do a parasitic draw if you still have a few modules still, you know, sucking some juice up? A little tip, if not sure, disconnect major modules last when isolating, okay? And that's one of the areas in diagnostic strategy that you might want to look at, okay? If modules start going offline, change the order of disconnecting modules to see which module is putting the others to sleep when missing, you know. So it just kind of like you're thinking backwards, going backwards, you know, and basically you're trying to decide which modules would not be relevant to the fault issue you're trying to tackle, okay? That's the first thing probably that you should do before disconnecting. That should also include the legs of these modules connecting to the network. And this could be a diagnostic time saver. Again, I'm just saying, you know, think about impossible, improbable, probable, keep it simple. You know, if it's something impossible, why would you even attempt to, why bother with it at this point? And those of you that have been watching, you know, my Lunch and Learns here, you know I'm a firm believer in keep it simple, let's not overcomplicate it. Okay? So I'm going to have here's an example. This was from a Isuzu campaign service bulletin, believe it or not, via the National Highway Traffic Safety Administration recall, and I'll get to that in a short too, After determining there's a fault, turn the engine control switch to lock position. And I highlighted in blue. Wait at least 3 minutes and then disconnect the negative battery cable. And on there you'll see important, the ECM may malfunction if the battery is disconnected within 3 minutes of turning the engine control switch off. Okay, basically, do we even think about stuff like that? Or more importantly, would we know about things like that? Wait at least 3 minutes before disconnecting negative battery. Boy, I'll tell you, if you didn't know, according to this could be an ouch moment, okay? Another example, this is one from Freightliner Business M2 Workshop Manual, wake state and sleep state. The bulkhead module, chassis module, instrumentation control unit, the ICU, are as a group basically in a wake-up state or a sleep state, depending on the vehicle condition. So when any of these electronic components are awakened, the remaining components wake up if they are not already awake. So basically when the BHM, bulkhead module, chassis module, instrument cluster unit, when they all go in a wake-up state, the odometer reading appears on the dash driver display screen, And those of you, for quite a few years, you've noticed you turn on the key, then they go through a dance, blah, 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 all the gauges, the needles move and everything else, and quite often, if you try to start a vehicle, depending on the vehicle, might not start until it goes through its song and dance, okay? One of the following actions will cause the bulkhead module, chassis module, or the ICU to go into an awake state. So now, let's get there. How about opening the door switch? It's as simple as that. How about turning on the hazard switch? How about turning the ignition switch to any position other than off? Turning on the headlight, park light switch. Even depressing the service brake, okay? Now, that same modules, the bulkhead, chassis, and so on, will enter a sleep state when they are no longer actively controlling any outputs or responding to any inputs and all other power down requirements. It's as simple as that. So now we know a little bit about wake up, sleep modes. Eh? Now here's another one. To check whether the electrical system is going into a sleep state, you basically enter the vehicle, shut the door, remove your foot from the service brake. Now you're trying to see if it's going to go into sleep state. Make sure the ignition switch and hazard switch are in the off position. Here's a little bit of note. 1 minute after these conditions are met, and provided that one of the parameters in that table that you see over here has not been added to the bulkhead module, the odometer reading should disappear. However, something got added to it, okay? The electrical system is not going to sleep. And this is just an example, okay? What can happen? The following is one of the parameters from table 1. I didn't put no part number on, but basically what happened is this thing that was added on is switch center pin power, okay? Guess how long? 24 hours. And if you guys have watched the automotive end with Chi and he's discussed parasitic draws and everything else, you know there could be a long time in between before these controllers, and depending again on the vehicle, on the model, on the year, when they actually go to sleep. So here's another one. If various modules are looking at the same sensor value, where's the source? Okay? Is every module looking at the sensors? They are somewhat, but in an indirect way. So for example, what modules need to see the vehicle? There's a slew of modules out there. You can revisit part 2, part 1, and so on. PCM, ECU, whatever you want to call it, TCM, transmission, instrument cluster, which modules get the hardwired values and which modules are networked. So basically there's got to be one of the modules that's going to get all the hardwired stuff. But what is the idea of multiplexing? What is the idea of CAN? You're going to network between the other modules, and you're only going to send the messages that resulted from these sensors. Now, think of all the possible modules and different systems involved in trucks. You got the PCM, you got the chassis, body, transmission, ABS, and so on. And I know I've mentioned third-party vendors, whatever way you want to call it, that get involved more so with vehicles with the bodybuilders. Each one of them with their own acronym, and there's just an example. Would you know the following? ICAN, BCAN, ACAN, FCAN, VCAN, MSM, MSB, MUX, EOJ, and that's just an example. I'll be honest with you guys, I'm not trying to say I'm dumb, but I wouldn't. But I would need to know it to walk through diagrams as an example. That's why information is important. Look, try looking at explanations, definitions, operation, and description as a very first step. And we're going to do that with that WAPCO thing. We'll actually walk through this. Okay? Now, for general diagnostics purposes, say, for example, you're going to go in there with a scan tool. I am not communicating. I mean, how can you get information if you're not even communicating? So right off the bat, in this scenario, you're going to have to somehow figure out, why am I not communicating? Okay? This might be any module or any specific network affecting network or entire vehicle. So again, where do you start? Where do you plug that scan tool into, right? The DLC, power, ground, terminal contact issues. Okay? Gateway possibly not connecting DLC to networks. Okay? Don't forget, the whole idea is your scan tool, call it whatever you want to call it, your electronic reader, okay? It actually becomes part of the network. What happens if you get a U code for bus offline? How can you diagnose it without duplicating the fault? How can you retrieve that fault code if that bus is offline? Okay. Possible causes, now you're going back to the basics again over here, right? Voltage drop. You want to get some good stuff, go to the Dorman Training Center videos, and you're going to see a lot of good voltage drop stuff over there that G has done, Peter Meyer has done. I mean, you got a wealth of information just on the Dorman Training Center. If you haven't, you really should kind of make sure you're online and you can always access it, link to it. Okay? But anyway, voltage drop causing a loss of communication during high electrical loads, such as during cranking. I mean, you're in a cold day and you're cranking and cranking and cranking. Let me tell you right there, you might have a high enough of a load that you're going to rob away from whatever the rest of the system's trying to do. Short in circuit, circuit noise. We talked about circuit noise induced from failed components. An alternator, I mean, it's maybe not kind of reaching out of the box, but it's sending signals out. What if they're getting into that communication data network line and it's kind of like, whoop, what's going on here? I don't understand this coming at me here, We kind of talked about pair twisting, improper pair twisting of those paired wires, okay? How about the U codes for shorts and opens? These tend to be more specific in description, and that's the nice part about getting the U codes, and it could be, for example, such as an open termination, and that's a good thing because now you know what you can measure, okay? So see multiplex part 2, okay? How about erratic communication, loose connections, electrical noise? Sometimes even open or incorrect termination resistance can cause this also. Open termination, okay? What are you talking about? The terminating resistor itself. How about also an open circuit near the terminating resistor, okay? I put a little note there. Make total network resistance as one of your first tests. Follow through also with a test at each module that contains terminating resistors. And again, we discussed that in Multiplex Part 2. You don't necessarily have to have a terminating resistor in your data line, okay? You could have them in the module. So it's all dependent on that manufacturer, that component, and so on. And also, we did go over again, and I put it in this one here, just in case there's some people here, this is, you haven't seen part 1 or 2, you know, so you do a resistance test, you get 60 ohms good, 120 ohms, one terminating resistor missing, and so on and so on, okay? Now, depending on the issue, you might want to ask yourself the following questions, and that's found in many of the diagnostic recommendations. I mean, you know, if you look at everybody's recommendations, you're going to have a kind of like a similar what you're seeing here. You know, of course you're going to start out, are there any lamps warning message displayed? Now, I got to tell you right now, and that's a bad habit. I have a hell of a time trying to tell myself when I pull a customer's vehicle in here, sometimes I get so busy, the one thing I don't look at is that light on, or whatever the case may be, whether it be for brakes or the MIL are on. And then all of a sudden, whatever I discover, whatever I fix, you know, I don't care what it is, and all of a sudden I go to pull away, ooh, the light is on, and now I'm scratching my brain. Uh-oh, was it on before? You know, or did I do something to cause this light to come on? And you guys know, I'm preaching to the choir. You go through this, you know, yourselves, you know. The big thing you want to know is, do all the systems operate properly? Make sure you know how they are meant to operate. Can the scan tool communicate with all the modules? Are there any controller module codes? The other thing is, yeah, I got a code. Are they current? Are they history? Okay. Does the module use terminating resistors? If they are, where are they? And big one for trucks. Again, we discussed the aftermarket, okay? So basically include in there, check for the vendor installed components connected to the data links. Because basically, if a vendor component or components are connected, do yourself a favor, disconnect them before performing any data link fault tracing. Right? So if vendor components are connected during data link fault tracing, faulty or missing signals can occur, and it'll lead you down that rabbit hole. And to be honest with you, when you get into these vehicles, and let's think about it, you got all these cameras and ELDs and these heavy-duty vehicles, somebody's always tracking somebody, and quite often I can't get in there, and I start unplugging their stuff, and voila, I'm in over there, you know. So that can be a pain in the neck, you know, and that's the vendors. They think they understand CAN, but they're not breaking in the way and helping us guys out. Back to the basics. Look, if a code is set at key on, stupidly simple. Chances are pretty good. It's a hard code and should be straightforward diagnosis. Operating conditions might cause faults to occur. Hey, hot, cold, you know. How about connections reacting to vibrations and flexing? Shorts related to harness position. There's recalls on that kind of stuff, okay? And with the harness, you know, the flexing, the touching, improper securement, okay, that can all lead to module power voltage drops, okay. Note, this can happen when power is shared with other systems components. I look at it as a good cause and effect, okay. Utilize network descriptions if available, okay. Check network code flow chart, whether you have a code or not, to see if anything sticks out for important information such as location resistors, master gateway module info locations, wake up strategy, we just went through that. Check for any pinpoint values that you might be comfortable with. Check out diagrams for twisted paired network to isolate from other components. And I know, I remember putting it in a future slide, ask yourself, is every wire that's twisted, is it a CAN related data wire? Okay, so be careful. Find the most direct route. find out what normal operation is so you can identify abnormal operation. Check for any technical service bulletins, okay? So, quite often, those service bulletins, they do contain good flow charts or calibration update information. National Highway Traffic Safety Administration, believe it or not, I had brought that up before. On occasion, they will get recalls. They can be another good source for information. Yeah. So let's look at this. Here's a typical recall over here. And I know you can't see it too good, but this one is for troubleshooting the after treatment control module, ACM, and downstream injection, DSI, assembly on a 2010 and 2013 Max Force, I believe, DT910 engine. Symptom happens to be intermittent or active codes associated with the ACM or DSI assembly. Even in this bulletin, and this is a point I'm trying to make, they say that a majority of concerns are found to be wiring and connection issues. Okay, and to be honest with you, when all you people get through doing any what you might call sophisticated diagnostics, just think about it. Where will you finally eventually wind up with? Terminal, wiring, and so on and so on. Okay? Now, how about this? This actually is from a recall. When's the last time you had a nice little beautiful wiring diagram? Okay, this is nice if you don't have access to information for every make and model out there, especially if you are the type of shop that works on anything that comes out through that door into your shop. Okay, it's almost virtually impossible to have every information out there. But you know what? Do your research. Okay? Now, this one here, okay? As you see here, the recommendation is to check all the connectors. I don't know how good you can see it over there, for proper contact by performing a drag test. Very important is, did the connectors snap together? You'd be surprised how often that winds up being the cause of an issue. I can't say enough about making sure the connectors actually got latched. And I see that constantly. It could be somebody else, someplace along the line, worked on that vehicle. Maybe they did some changing of sensors or whatever. Codes are on and stuff. Man, I'm so into the habit of going back again, check the connections. You know, you guys know how hard some of these are to put together. You think you have it together and they're not together. Okay? And this is nice. Okay? The nice thing about bulletins, to be honest with you, is, and recalls, by the way, is they exist because of known and documented issues. Take advantage of this. Somebody, and that's why I put it in there, someone else did the work for us. Okay, and you wouldn't see those bulletins unless they've had issues and they've constantly been back to the dealerships and stuff. And if it affects safety or something, okay, stability, fire hazards and everything, it will wind up being a recall pretty good. The chances are pretty good on that. Okay? So this is another one. Okay, this is where I got that little tidbit about waiting 3 minutes before disconnecting the negative battery. The one sentence says, please review the following information to ensure that it conforms to your records, as this information is being made available to the public. So this is part of the recall. You can't see it there, but in this particular case, the reason I'm heading this way, here's an overloaded electrical circuit from wiring damage. So let's see what we're going to get from this. Okay? This you should be able to see. Okay. You see up there 2,891. You got quite a few vehicles that are involved in this recall. Also, you will notice that third-party vendor, whatever you want to call it, add-on is involved in this. In this case, it is the Mobileye collision warning system that this particular vehicle uses. Okay, and it suggests that there's an issue with an improperly routed camera cable. Consequently, the wire damage to routing installation can result in electrical overloaded circuit. So this is a perfect sample. The reason for the recall is actually safety concern, risk of overheating causing a fire, and of course loss of turn signals, which is, you know, hey, we got to have those, right? Hazard lights, and or in this particular case also, it does serve as a collision function, okay? But any of those above will increase the risk of a crash. Therefore, is for you to have out there, public out there, so, you know. Now, what can I learn from this recall besides the obvious? Okay, and I put an arrow in there. It says wiring for Mobileye collision warning system may have been routed incorrectly, and it could overheat and melt. Okay, that makes sense. If this happens, turn signals and hazards may not work properly. Okay, then the way, I'll be very honest with you, the way it works, I'm not, you know, we're not going to go through the whole thing, but if you want to know if do I have an issue, okay, this is just for your information. Turn the key on, engines off, move the turn signal lever to the left turn or possibly the right turn position, and you want to confirm that each indicator on the instrument panel operates properly. Confirm that the light on the Mobileye camera is on and no codes are present in the iWatch display. So basically, if one or both of the turn signal indicators do not function properly, okay, so for example, if you've run across those both indicators flash simultaneously, chances are pretty good the camera cable must be replaced. So I went in a little bit differently here. Now, I went in there, okay, and let me get, see if I can find this real fast. You want to zoom in on this? All right. Oops, let me, sorry. I need to get the camera on me. Sorry, Lena. But basically, I did a research. Okay, here's a Hino truck and so on. Okay? And Mobileye, so I wanted to see what this Mobileye is all about. And this, all I did was I Googled it and I went online, okay, and I printed out a network procedure, how to replace the wires and everything. Don't have time to go through the whole thing, but it basically started with this particular recall over here. The one that I had on the slide, you'll see NHTSA on the bottom over here, you know, and they did a really nice job on this. This is Isuzu, okay, the Mobileye, oops, and it walks you through page after page, similar to what I showed right from the manufacturer, all right? So now, you can back out. So now, let's get back to this again. Okay. So I'm running across and I'm going through the pictures over here, okay? And I'm running across this, I'm saying, what is this? You know? I'm saying, oh my gosh, I'm seeing some wires going through there, you know, and it's like, you know, I'm kind of maybe looking at it, you know, is this some kind of a Scotch lock thing, you know, guys, please, we all know about Scotch lock, okay? And it gets pretty specific what you have to do with this, you know? So now, okay, I figured if they went this direction, it's an important enough of a component to have a full step-by-step on how to install it. And like I said, for me, it looks like some kind of electronic device that wires have to pass through. Scotch lock again? No, I'm just kidding, you know. But if you look at that, you know, I had to question, what is this? So I had to go and do a little bit more research, and this is how we all learn. So what this is, you know, it's a CAN reader. It's a convenient way of making connection to the CAN network without splicing in, okay? But guys, it is another electronic device that could possibly fail. So if you didn't know, you might be going down a rabbit hole. How deep do you want to go before you figure it out? Okay, and I'll be honest with you, I've been in some pretty deep rabbit holes, you know, so, but then again, everything is a learning process, okay? Wiring diagrams. I don't want to get too much. I only got time, limited time, but take your time on this. When you look at wiring diagrams, look at the legends. Try to figure, you know, you're looking at a road map. What does everything indicate? What does it mean? Those symbols, the other identifiers for the diagram you're working with. Use highlighters to identify crucial wires. Why are you looking at 10,000 wires when you only need wires that are pertinent to this particular issue you're trying to do? To isolate those specific wires. Take note of shared power and ground circuits. That's important. And again, if you got a printer, print the diagrams out so you can tape them together. I'm being a wise guy, but I have had to do that because you get some of these vehicles, it's like it's never ending, and I don't have time to try to make the connections. But if I tape them together, I can maybe possibly somewhat go from point A to point B uninterrupted. Okay. Plus, also, don't forget, you can make notes on it with any tested values that you can go and try to reference first. And to be honest with you, it's like anything in life, this way you might possibly look at this complete picture, this complete what you did with the highlighters, and wow, all of a sudden you get that bingo moment when everything comes together. Most issues will wind up being network wiring and connections. Lab scopes are, I didn't do the, just bear with me. I'm having trouble following the chats here. Okay. Good stuff. That's what I'm talking about. Okay. Deutsche connectors, George, absolutely. AES Wave has a real good article on color coding, you know. So, but back to this, okay. Most issues will wind up being network wiring connections. Lab scopes are good for looking, but what happens if there are no messages to see? Digital volt ohm meter, test light are still useful to look for available voltages. Test light can be used to check DLC or module power and grounds, but be careful, guys. Always test lights, be careful. Signal generators can be utilized to check the signal resistance at a location, measure it for a DVOM at every, measure with a DVOM, a digital multimeter, whatever you're comfortable with, at every location that is utilized in the network following your highlighted diagram. Now this will bring us to wiring and proper repairs. When do you repair or replace wires? And that's a legitimate question. You know, the terminals are harnessed. And I looked at so many different sources, you know, and everybody has their own little, you know, but I think I'm pretty close to some, you know, where we come to somewhat of a consensus. You know, for example, here's from a Freightliner service bulletin. Repair if less than 20% of the harness damage. And again, to you guys, it's your judgment call. Or if the wire damage is greater than 6 inches, an overlay harness can be added. Overlay meaning, you know what, cut that 6 inches out there and put another section in there, okay? If wire is smaller than 12 gauge, if wire insulation is cracked due to excessive heat, if corrosion is wick no more than one, that wicking is, we make those mistakes. We get that wicking in there, and we put immediately, we don't go far enough, and we just put our little terminal end on it. But that's, guys, that, you know, again, I make that mistake. I get in a hurry once in a while. In this case, if the damaged area is over 6 inches, harness can be repaired by adding overlay wiring over the damaged area. Okay, so again, if you do cut a bad section from the data link, replace it. Keep the following in mind. Make the replacement section a little bit longer than the section you cut out. And that will basically allow for staggering of the splices. And a lot of us forget to do that. We kind of like bundle everything together. It's like you got a huge big bundle in there, you know. And don't forget about using heat shrink tubing to seal the data link. And of course, you know, of course, shrink butt connectors, you know. Guidelines: replace harness when more than 20%. Now we're looking at when do you replace a harness. Wire is 12 gauge or larger, wire insulation is cracked due to age, other environmental conditions, and the damage is spread throughout the wire harness. Harness is proprietary, you know, then of course you're going to wind up doing it. Harness is used for data linking with sheathing over a twisted pair. And that's kind of hard to do. So this is a kind of a guide, you know, about when you should replace the harness. What about connectors and terminals? Consensus seems to be that damaged connectors, seals, and terminals can be replaced without replacing the harness. However, if you're going to make that decision, drag test is crucial for determining. And it really, the drag test kind of, you know, gives you a go, no go, and really affirms that I really truly do have an issue. So don't rely on a visual alone as the determining factor. And here's an example of a drag test. You know, it winds up about having the feel, and that's important. You know, what your feel. Do me a favor, turn this over here. I think I might be able to, yeah, oops, let me switch over the camera here, yeah. And if you can see this, can you zoom in a little bit better? Okay. So basically, what do I use for a drag tester? Okay, so for example, I have this little, my connector, and if you just zoom in on this from my OTC connector, and on this one end, you know, so you can zoom out a little bit, get me over here, you know. So on this one end here, this was where I would connect to my digital volt ohmmeter, lab scope, or whatever. But however, this is a very pretty close to spec. So basically, oops, sorry, got the dropsies. So if you can hone in, and the reason I said it's a feel thing, I put them in here. Now this one is loose, okay, and if I put one in here, okay, wow, this is tight. I'm having to really tug on this to get this out, you know. And again, it's a feel thing, but now the loose one assures me that I have an issue, especially if you compare it to the other terminals. It won't take you long to get the feel of what you're trying to do. So we'll get back to the PowerPoint over here. Okay. Guidelines. So this is an example of not replacing a harness. So, but however, in this case, all or many of the wires, you know, basically not all of them, they head to the fuse box, you know. And to be honest with you, this is a kind of a nice little job. You know, you can get the terminals from so many places. Sit down, get yourself a cup of coffee, you know. It's the only thing that you're going to have keeping your company. Turn the radio on too, of course. And again, it's a tough world. Somebody has to do this, you know. But if you have the proper tools, okay, if you have the proper tools, you can do all this. So if you turn back to here over again, you know, I just randomly, oops, I keep forgetting to switch this slide over, sorry. If, you know, turn over here. I am so, you know, terminals. To get them out, I got all sorts of little terminal removers, you know. I got them for the weather packs, metric packs, you know. I've had these for years over here to go in there, you know. And then when you go and put them together, this is the type of plier, you got the anvil and stuff, so, you know, make sure you got a good crimp, okay? Then, of course, everybody knows how hard it is to get the connections off. They can, especially if they're out of the way, they're buried someplace. I mean, I got all sorts of stuff trying to make my life easier. Okay? So, back to the slides. You only have one set of wheels to go back and forth to work. This is a question. Of course, go shopping and drive your family around. Now I'm turning this into a personal thing. Always treat your customers the way you would yourself. Your vehicle cranks but won't start or run properly. You do a quick diagnosis because you need your vehicle, and you discover you have a burnt section of a wiring harness preventing the engine from starting, running, whatever the case may be. Bad enough that you know you should replace the harness. However, guess what? That harness is on back order and you might not see it for a week or two or month. My question to you is, what will you do? Welcome to the real world. If you are like me, in necessity, I need my vehicle, okay, I'm going to do whatever it takes to repair that harness. Right? Does that happen in fleets and stuff? You bet your boots it does. But even in those cases, at a minimum, make the repairs using proper techniques to minimize any future issues. Okay? Here's a perfect example. This happened to be a Bendix ABS, and I'm going to go through real fast. Okay, time constraint, leading to a bad terminal at a connector. Okay? I use my terminal remover things that I showed you before. Okay? And of course, you know, if you're working with twisted wires, with any wires, stagger the wiring cuts. I already mentioned that, and the splices to minimize bulges. Always, in case I forget to mention it, observe polarity, especially if you're working with connecting CAN H yellow, CAN H green. Actually, you know, forget about CAN, all wires, you know, because you have components out there that are polarity sensitive, you know, and you don't want to go backwards, you know. And I threw this in, you know, I learned how to sew in the Marine Corps, need to keep my uniform spiffy. Obviously, I never told my wife, of course, you know. Let me go back. I was excited about the slide I put, okay? Because needless to say, if she knows I know how to sew, okay, you know what? I really did not want to become the family seamstress, you know. So again, just a little thing. If you zoom down over here, you know, and I'm not going to take the time right now, but right here, this little baby over here, okay, you go in there and it's pointed so you can miss the wires and stuff. If you use like razor blades, you know you're taking a chance of going into wires. So here you go. Boom, 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 you know, and that's pretty tough, this cloth tape, and you're done. It's as simple as that, okay? So you too can become the family seamstress, okay? Typical CAN discs, and this is where we're going to get into, we're actually going to use a little bit of, I was looking for a way of doing it easily. And like I said, I do ABS training, so I was looking for a way, because if you get into engines and stuff and, you know, whole shebang, transmission, put them all together, it's kind of a little hard to kind of like, you get a little bit of a cluster, I guess, you know, where I says, you know what, I got access to all this materials here, you know, Meritor Wapco for years have been very generous with me, so I went in this book and I started to follow it, you know, what is it about and everything else, and that's basically what we're going to do. So here's my maintenance manual from here, and they did a hell of a job. So I'm going to go back on my PowerPoint again, okay, and let's see what kind of trouble we can get to. Again, you might not see this, okay, and this is a content sequence, okay. Now, this involves the stability control, and maybe we can learn some other stuff out of this, okay? And basically, what happens, you see it in the red down there, you retrieve codes relating to SAS, CAN, ESC module, and ABS ECU. And my whole idea is, what's the next step, okay? And even at that, if you can't see it too closely, and again, you will see that in most of the issues we have, one of the recommended actions is to check CAN wiring between ABS, ECU, and SAS for interruptions and short circuits. Okay, we're back to wiring again, okay? And basically, let's simplify it. In this case, you're going to check for corroded or damaged wiring between SAS and ESC module. So now, let's put it all together. Did we learn enough to do all this? I think so. Within the 3 weeks, a little short lunch and learns. And this one, you can see a little bit better, okay? You're looking at the diagnostic sequence over here, and if you can't, okay, you can see here a little bit better. Like I said, we're looking at communication issues, ESC CAN data link fault. The guidance again is checking CAN wiring between ABS, ECU, ESC module. Again, that means my next step is I kind of need to get a description of all this SAS and what are they doing and everything. But before we do that, just I at the last minute, you know, before we get back on board with this WAPCO thing, okay, I mentioned, did we learn enough? I hope so. One more tip. Identifying an open circuit is one part of the diagnostic. So using an overlay, just so everybody understands an overlay, installing a temporary wire to verify that communication is back on with all the modules. Okay, so we can use that, you know, as to our benefit. So I just thought I'd throw that in there, you know, a little bit of a shortcut. But back to this, okay. This should be applied to any communication, electrical issue. Just substitute components, modules, that previous one, excuse me, that I was saying here, you know, that's the whole idea. You know, what if a network has resistors that are electronically connected? I jumped ahead again. So they are open unless they are powered up. Check any available circuit descriptions. So now, let's get into this, okay? This should be one of your first steps, okay? Start with understanding the system and description of components involved. We talked about the ECU, okay? So in this particular case, the description is in there. The ECU is control center or brains of the ABS, okay? Roll stability control, electronic stability control. It receives information from the sensors, processes data, sends signal to modulators and active braking valves to achieve different tasks. So far, simple enough, okay? Now, here we have the SAS, okay? Just so you know, when you can read through here, it says, I put it in blue, the ECU supplies, okay, by the way, steering angle sensor. So if you didn't know what SAS, tells you right there, okay? It's part of the ESC system. I did put in blue over here, and that's a very important clue. The ECU supplies a sensor with voltage and ground, okay? And I mentioned something in there. It's just as a side attraction, calibration, okay? There's a heads up. If these components, the SAS, ECU, and the ESC modules have to be replaced, you're going to have to do an end-of-the-line calibration. Okay, this calibration should also be performed, just so you know, okay, if you have a major steering repair or replacement has been done, you know, you got an accident, whatever the case may be, okay? Not even for those, how about just after front wheel alignment, okay? They're suggesting you should do this calibration, okay? Just a little tidbit. If that SAS calibration was completed before ESC initialization, so there's a lot to it, you might wind up that the ATC lamp will be continuously blinking before ESC initialization begins. So there are some side steps, you know, but you have all that information, okay? Now, here's the other part of it, the other component, the ESC, Electronic Stability Control Module, okay? And you can read in here, the module is part of the ESC system, measures the yaw rate as well as vehicle lateral. Module includes parts of the ESC control algorithm and so on, okay? Now, just so you know, these modules, the ESC, they're installed by the OEM close to the vehicle center of the gravity. Okay, I don't have that on the slide, but that is very important, that location. Okay, the ESC might face towards the front of the vehicle or rear, but you always want to make sure the ESC module is correctly leveled. Do not move the module to a different location, because this will affect the system performance. Okay? Now, you have enough information there, okay? I'll be very honest with you. This one threw me a little for a loop. Not everybody has as much as it should. So I'm going into this segmented schematic here. And just when you thought you knew everything, okay, sometimes the manufacturers play the engineer card with us, okay. I kind of thought this was a supply voltage. Where you see over there, it says UB. If you can't see it too good, I'll try to highlight it here. Get my magnifying on. It's not coming on. Son of a bitch. But right there where the arrow, it says UB, okay? And basically, okay, what is this UB? It's base voltage, also referred to as operating supply voltage, okay? So I'm kind of like, okay? Now in my next slide over here, electrical checks. We're going to take all this, do some checks. For following checks, all the ECU connectors must be plugged in, as well as the SAS. ECU provides voltage, ground, and communication to ESC module. Okay? Remember that description about the SAS before? So you're going to take measurements at the ESC module harness connector, measure voltage supply key on, measure CAN high voltage key on, measure this. Look, I'm going to buzz through here. You're going to have the handouts, okay? So you need to slow it down. You know, the handouts are yours. You use me as a reference here. The frame-mounted ECU, measure ground resistance, key off to chassis ground. Okay, the nice thing about this, and this is why I chose WAPCO, step by step, you have a lot of, lot of good schematics information over here. Verify no short to ground or battery on all lines. How do you do that? Verify continuity end to end on each line. Verify no continuity between pins. So you have the pins, you have everything there to work with. Okay. And you also have, what am I supposed to see for a measurement? It's right there, guys. There's your pins 1, 2, 2, 3, 4. And like I said, you might have to go back and forth. But as we continue this journey, you're going to see that the values, doesn't matter what the modules are, what nodes or whatever, if you're looking at data, you're going to wind up getting pretty close to the same concept and same values, okay? So I threw that in just for heck of it, typical CAN testing sequence using, basically what you're looking at here, I'm just trying to show you that you don't need sophisticated tools. However, I got to tell you all day long, a good electrical understanding and meter usage understanding, it definitely is a must in today's world. So step by step, you can go through that, okay? This, again, what I'm showing you here, they're a good example of what happens when the electrons leave the source. How do they get back? What dictates some measurements that you're looking at? You want to know how do series and parallel circuits work? Resistance high, current low, resistance low, current high. What effect does that have on voltage? So if you get a good grasp on that, you should never hit the wall. I do 2-day electrical classes here, but if you can't do classes like that, she does them over at his place, okay? Dorman Training has shorter classes and online training that are really kick-ass by a number of the greatest trainers, instructors that you're going to run across. Don't get me wrong, anybody that does this kind of training, they're all great, but I need to tell you that, Dorman has some good stuff. And again, we're doing the same thing. These are measurements. We went through looking at the DLC. Think about all the sub-connectors. Again, nothing changes. You're doing the same thing. You're isolating, looking at the system measurements. So here's another one. You have them in your handouts. Okay, check ground for battery voltage and so on. Okay? Again, check CAN lines for battery voltage or ground. Connect between 3 pin and 4. Everything is guided for you. You know, are you getting the right measurements? There's your CAN high voltage to chassis ground. Okay, you got the specs over there. You know, typical CAN testing again. ESC module connector. You know, it's same thing. Okay, and you'll find that the commonalities are there for all of them. Okay, and again, steering angle sensor. Disconnect the SAS. Check terminating resistors. Pin 1. And if you follow this, you know, I don't want to take the time right now, but here's some more electrical checks. Still doing the similar checks. This time it's the steering angle sensors. You know, are you still expecting performing similar tests and looking for similar measurement readings? Yes, you are. Okay, all day long. Okay, so again, when you look at this stuff, I put down there, revisit multiplex part 1, 2, and of course you got 3 here, and you will discover that everything we learned led us to this sequence. Commonalities. Okay, here's an electrical check. This is actual serial communication testing. Okay, good resistance check. Test is checking resistance. Network to ground. Connect your ohm meter between network circuit and good ground. You should have infinite resistance. And by the way, just a little side note here. Realistically, manufacturers design networks with some resistance to ground. You're never going to have a total. Okay, you're only talking about thousands. Just had to throw that in. And you can do the same thing, network to power. You do the same as network to ground testing, except this time the ohm meter ground lead is moved to a power source. Okay, and anytime you do ohm meter testing, guys, keep it in mind, very important, make sure the power source is depowered. Okay, and make sure, of course, you're going to have to make sure which power sources you might be shorted to. Okay. Now, again, should read as follows. You got all the information and so on, and we're getting close to over here. And finally, okay, we're looking at the wiring diagram, and I highlighted the grounds on this, and I called it follow the yellow brick road. Okay, and I follow it. Again, we're talking about, you know, going from diagram. Okay, this is a reminder. Go back and look at slide 45. Remember, what is UB? That schematic shows the path of supply and power. Also, slide 43 description, the ECU supplies the sensor with voltage and ground. And now you can look at all this stuff here. See that? If you look closely, you will see the ECU plus and battery. Also on bottom, you will see the ground. So we come to the end of the road here. Okay, look. You can use so many different strategies, isolate, substitute, overlay, and so on. Once you're comfortable with the circuit, the diagram can help you find so many different directions for diagnosing. You can even practice in your mind if you want. With, you know, take this, what we did, practice it, substitute, I don't care what it is, transmission control module, whatever, but you're gonna wind up doing basically the same thing. Let me kind of see if I can scoot down on the chat box, because like I said, you guys know by now that I do I try to put 10 pounds of whatever into it, you know. Chino, if battery goes dead, steering wheel is off center, recal. Yeah, there's so many things. Checking wires such as red or black jumper wire and slide. Would you use a needle type wire piercer for temporary you know what? That's a good thing. That's a good question. I'm surprised a few years ago, I ran across an article by GM, and we always have the kind of conversation, you know, should you pierce, should you do this, should you do that? And they kind of made sense, okay? So if, zoom in on this, okay, if you could please. Now, this is, I don't have time to get the right one, but I didn't bring my piercing stuff here, okay? But I'll be very honest with you. So if you pierce in here, we're talking about piercing in here versus here. Well, the ones with the weather pack, sometimes you have to go so deep in here, and I have actually run into a problem. Gee, I can't get a reading, I can't get a connection, or I get a reading, it's a wrong reading because I went in a little bit at an angle. This can send me down the rabbit hole too. So, and again, I'm not promoting any certain, and you can back off here, I'm not promoting any certain way of doing things, but with today's technology we have where we can actually seal this and everything, their recommendation is that, Adam, let me put it this way, food for thought, think about that, you know. So, you know, but that's a very, very, very good question over here, you know. So, and again, today I see, you know, Chino, do every battery goes dead. I mentioned that already. Absolutely, you know, so much of everything we touch today, you know, everything winds up with initializing, recalibrating, and so on and so on. So we're running out of kind of time here. Whoops. You guys were doing pretty good with the questions over here, okay? If you're still hanging in here, okay? And I'm sure there's hundreds of questions, and you can always save it for the next lunch and learn and so on and so on, okay? Doreen put the link for the handout again out there. And do me one favor, okay? I'm not quite sure. I'm hoping we seem to get a pretty good attendance with these lunch and learns, but there's a QR code on there. If you could do me a favor and snag that picture over there, and if you would please leave a survey, excuse me, you know, does this work, does this not work, you know, maybe there's something else you guys are looking for, you know, because we're one of the few in a heavy-duty independent that we're trying to really reach out and, you know, give information to everybody, you know. I know there's a lot of dealer trainings and stuff, but not everybody has it, you know, and I would like to think that we're doing a more of a personal one-on-one thing. So I'm gonna call it here if there's no more questions. I'm still looking at the chat box, and that's what I'm pointing at the chat box. So if you guys are good,